Today, I'm going to discuss how to solve the transportation problem. This is a transportation problem, and these are the sources, that is, the plant producing the product, plant A and plant B. And these are the marketplaces, that is, warehouses, W1, W2, W3. The capacity of the plant A is 300 units, and the plant B is 500 units. The requirements are, for this warehouse or marketplace, the requirement is 300, and for this warehouse, the requirement is 300, and for this warehouse, the requirement is 500. Okay, and these are the transportation cost. Transportation cost means from this source or plant, if you shift one unit to these warehouses, this warehouse, then the transportation cost per unit will be 25. And if you shift one unit from this plant to this warehouse, per unit transportation cost is 25. In this way, all transportation costs are noted. This is a 2 by 3 transportation problem, and you have to find out the optimum schedule, that is the best schedule, that is from which source or plant how much quantity is to be shifted to which warehouse, so that the total transportation cost will be minimum. Okay, I will solve this problem in 2 steps. First, you have to find out the basic feasible solution. First step is to find out the basic feasible solution, and the second step is the optimization step, that is to be done by MODI method, that is modified distribution method. That means this transportation problem will be solved in 2 steps. First, finding out the basic feasible solution, and the next step is optimization of the transportation problem. Okay, now I'm going to start. First, I have to find out the basic feasible solution. I've already discussed several times that BAM method is the best method for finding the basic feasible solution to solve any transportation problem. Okay, that's why I'm going to discuss how to find out the basic feasible solution by BAM method, means Vogels approximation method. The first step is, that is, first you have to check whether it is a balanced transportation problem or not. Balance means this is the first steps you have to check. If it is not, then you have to do something to solve it. Here the total availability or capacity of the plants are noted as 800, and the total requirement 300, 300, 600, 1100. That means this is an unbalanced transportation problem, as the total availability not is equal to the total requirement. So before proceeding to find out the basic feasible solution, first what you have to do? First you have to make this transportation problem as balanced transportation problem. Balance means you have to add 300 units, 1100 minus 800, 300 units to availability or source, and that is called dummy source. To make the problem a balanced problem, only then you can proceed. Now I am doing that step, then only we can solve. Okay, that means you have to add one source to make it balanced problem. That is called dummy source. That is called dummy source. It is better to write the same color. Dummy source. This is called dummy source. For mathematical purpose, you have to first make it a balanced problem. So how much you have to add here is, that is 300 units, and in the given problem the requirement was 300, 300, 300, and then 500 and 500. Now so check it. This is 1100, 1100, and here is also 1100. This is the first step. First step means first step of the BAM method or basic feasible solution method. Okay, so again I'm repeating what you have to do when you have to solve any transportation problem. First you have to find out the basic feasible solution and then optimize it by modeling. Okay, and before starting to find out the basic feasible solution, you have to check whether it is a balanced problem or not. It was an unbalanced problem, that's why I have added the dummy source 300 to make it is a balanced problem. Now see, then what will be the transportation cost? The transportation cost you will put as 0. What is the significance of it? 0. 0 means as if the materials are not being shifted. It is produces only and it remains in the factory. That's why it is a dummy factory, you can say, to make It's only a balance problem. Okay, now it is a balance problem. You can proceed for finding the basic feasible solution. Okay, I am using the BAM method. Okay, I have already discussed in several problems how we find out the basic feasible solution by BAM method. First, what you will do, row wise, you find the lowest element, lowest cost. Right? Which one is the lowest cost? 70. And immediate lowest cost. Immediate lowest cost is 25. And you note the difference. 18. Sorry, so 25 minus 17 is 8. Whatever which is. And same process you have to do for the second row. The lowest cost is 10 and the immediate lowest is 15. Therefore, the difference is 5. Okay. And third, 0 and 0. That means difference is 0. Same process you have to do for the column wise. Lowest cost is 0, and immediate lowest is 15. Therefore, the difference is 15. And for the next column, 0 is the lowest cost, and then 10, that is the difference is 10. And for the last column, lowest cost is 0, and the difference is 18. That's why the difference is 18. After doing this, you note the highest difference. You have to find out the highest difference, 8, 5, 0, 18. Out of all this is the highest difference. And this indicates you have to allocate in this column. And why do you allocate? And you have to allocate on the lowest cost cell. This is the lowest cost, not this, the lowest cost. You have to allocate here. And how much you will allocate? 300 and 500. The minimum of this you have to note here. 300. You have to put here 300. That means the total 300 units is exhausted, and the requirement, as you have already noted, 300, the difference about you have to shift, still to be shifted. That's why, as the total units has been allocated and there is no scope for shifting, that's why we will strike out it in this way. Okay, now the revised table will be this. I'm erasing this part. You have to do in your copy a separate table, but just to save the space, I'm erasing on this same table. Okay, that's why now this is table 1. This is, you can note it, this is table 1. Now I am going for table 2. What will be the table 2? You will erase it. You erase it, this part. Why erase? The 300 units has already been exhausted. This is the table 2. Okay, allow me to tell me done. This is table 2. Now I am going to do for the table 2. What is the availability? For 300, 300, 300 and 500. Not 500. Now how much you need? Because already you have allocated 300. That's why the remaining requirement is 200. You can check the total requirements and the total availability will be same, always same. You can check it, but it is not required in every step. But I will show you as it is the first step. 300, 300, 800. Okay, always it will be same. Now again I am using the hand technique. As we have done in my previous table, the similar process we have to adopt. Lowest element is 70, the immediate lowest is 25, the difference is okay. The lowest is 10 and the immediate lowest is 15. That's why the difference is 5. And column wise, if you check, the difference is 10, lowest and immediate lowest. The second one is 7 and last one is 18, and this is the difference, lowest and immediate lowest. Again, you have to find out the highest difference. This is the highest difference. You can check this is the highest difference, and you have to allocate on the lowest cost cell. This is the lowest cost cell. Clear? How much you allocate? 300 and 500. Out of this, the minimum units, that is 300. 300 have to allocate, and the requirements will be 0, and again you have to shift it. This is 200. In this way, you have done the table 2. Now I am coming to the next table. Okay, next table, I am erasing it. Why erasing it? Because next table it is not required. Already the total required quantity has been shifted. That's why that's the same table we are doing, but you will do it in a separate table in your copy. Now just to save the space, I am doing this. Okay, this is, I am erasing again this part. I am again erasing. This is A and B. This is A and B, and how much it is? 300 and 200, and here is 300 and 200. as we have already allocated 300. You can check 500 and 500. Okay, the same process you have to adopt. Minimum cost and the immediate minimum cost is the difference is
How many?
8. So this is 8. Okay, and vertically this is 7 and this is 7. The difference of lowest and immediate cost. Then where is the highest difference? The highest difference is this. As the highest difference is same, you always consider the uppermost row. This is the convention. Okay, you should follow a rule. That's why I have taken this highest difference, not this. So that the allocation should be on the highest row and the lowest column. That's why here. So where it will be allocation? The allocation will be here. This is the row wise. The lowest cost is this 300 and 300. How much the allocation will be? The minimum of this is 300. That is also 300. That's why the requirement is 0. The requirement is sorry, this is the requirement. The availability is 0. No, for the total only this part is remains and the final allocation will be this 200 because only this cell will be remains. This is third table actually. You might need this is third table. And finally, as this is the only cell remains because this is exhausted and this one is exhausted. Only this cell is left out. That's why 200 is allocated here. In this way, you have to find out the basic allocation. The basic allocation is from plant A to warehouse W2, 300 units will be shifted. And this indicates from plant B to warehouse 3, you will shift 200 units in this way. Now, I am writing the final allocation table, basic feasible solution. Considering the basic feasible solution, the final allocation will be this that I am writing down. And after that, we will apply the second step, that is modding. Mod I will apply the modding. Okay, this is 2y 3 transportation problem 2y3. This is 2y3 plant A, plant B, whereas W1, W2 and W3 and the cost is 25, 17, 25, 17, 25, 17, 25, 25 and 15, 15, 10 and 18. And the basic allocation is 300. This is 3. You check 300. Already you have done this. You check for the previous tables. You can see A to W2 is 300. It is just have to take it. You can check it. There is also one dummy also. To top that also. Yes. Dummy. 300. 300 and 200, this is 300 and this 200 and finally this is 300. You can check the total requirements is 300. You can check whether you have done any mistake or not. This is 500 and this is 300. This was the total capacity and the requirement. This is 300 and 300 and this is 500 and you can check the total. This is 1100 and this is also 1100. And this is the basic feasible solution which is found out by the hand method. And the total cost for the basic feasible solution will be 300 into 17 by 370 per unit transportation cost from this source to this warehouse is 70 and 300 units you are going to shift. That's why this is the cost plus 300 into 15, 300 into 15 plus 200 into 18, 200 into 18, 200 into 18 plus 300. The cost is 0. Already we have discussed. Actually, for dummy source, the cost is 0 is considered as if the material will not be shifted here. Production okay, वहाँ free हो जाता है. That's why. And what is the total cost? And you can check it. Rupees 1300, 13,200. This is the cost for initial basic feasible solution, which is found out by BAM method. But this may not be the best. This may not be the minimum. In the case of transportation problem, as we are considering the cost, that's why we will find out the minimum cost. But this is the only the initial basic feasible solution. That's the starting point. Whether this is best or not, that we have to check by another method, which is called MODI method, that I am going to discuss in my next video. So up to this, we have found out the basic feasible solution. These are the basic allocations. These are the basic allocations. This is the basic cells. Basic cell, this is non-basic cell, this is non-basic cell, like that. And how we'll optimize by model, that I will discuss later. Thank you. In my second video, please see the next video. Only then you will understand how a complete solution is done for transportation problem. Thank you.